Good evening. We are going to look forward towards this concept which is called momentum. Now we know that momentum is given in physics by the small p equals mass times velocity. So p equals mass times velocity. This is the basic formula of momentum. Now mass is measured in terms of kg. That's a unit of measurement. And velocity, we know it being a vector quantity, is measured in terms of meters per second. So we get velocity in terms of meters per second and we get mass in terms of kg. Now what we need to know is that mass is a scalar quantity and velocity is a vector. Because vector, why? Because it has got both magnitude and direction, whereas mass being a scalar quantity. And that is the reason that we get momentum, that is P, is a vector quantity. So we write it as P is vector, that is the momentum is vector. Now when we talk that momentum is vector, we mean to say direction, which can be in this direction. This is the positive direction which it is moving. And in case that we get that we are moving in this direction, it is the negative direction. So if we get a direction which is moving towards this, we get a positive momentum. And in case we get a momentum direction which is moving towards this, it is going to be a negative momentum. So we are more going to look towards this negative momentum at the present, because we know that positive momentum, what it is. But what is this negative momentum all about? Now we take two balls. For example, the first ball is weighing around 5 kg. And the second one is around 10 kg. These are the two mass of those two balls. And it's going to be the same on the post-momentum part, that is, it will be 5 kg and 10 kg. But what we are given is that this particular 5 kg ball is moving towards this ball at a velocity of 5 m per second. This obviously has been stationary, so it has got no velocity. What we need to know is the velocity of this particular ball, that is the v, and given that this 10 kg ball will be flying off at 3 m per second. So this is the scenario. This is moving at 5 m, it's the stationary. This ball, we need to know the momentum at this 10 kg is moving at 3 m per second. Now we know that by the golden rule of momentum, that the total momentum before the collision is always and always equal to the total momentum after the collision. So what is the golden rule? Total momentum before the collision is always going to be the same with the total momentum after the collision. So from this particular equation, that is P equals mv, what we can get is that we can write that is mass, which is a 5 multiplied by 5 m per second, which is this one, and plus this one, which is the 10 kg one. Obviously it is 0 because it is at a stationary. It is always equals to 5v, because we don't know the v as yet. There's a velocity, we just write down its mass, plus 10 multiplied by 3, it becomes to 30 m per second. It becomes to 30 m per second. So solving, what we get is that 25, this is the 25 equals to 5v plus 30 m per second. So if you just shift and flip over to this, what we get is that we get 5v equals to minus 5, shifting over, and we get v equals to minus 1. Now you see this v equals to minus 1 m per s. What is this all about? This is what we are talking about when we get a direction which is moving in the opposite part. That means this particular ball, when it is hitting this 10 kg ball, this particular 5 kg will be moving and recoiling. This term we use, we know at recoil. That means it is going to move backwards towards this at a velocity of minus 1 m per second. Minus 1 m per second. So this one hitting this one, and this is moving, the ball, 5 kg ball is moving towards the left, that it is recoiling at 1 meters per second. And that is exactly what happens when there is a gun and you're firing a bullet. This gun which you're holding on your hand is going to recoil, and that is the reason you receive a thud, you receive a shove on your wrist, because it is recoiling towards this direction. So to sum it up in all, what we can tell you that we have got a mass of m1 and m2 before the collision, and what we get is this m1 and m2 obviously is going to be this same, but this is moving at v1, this is moving at v2. This mass is got a new velocity v3 and v4. So what we are going to get is that m1 plus, let me write it, m1 v1 plus m2 v2 is always and always going to be equal to m1 v3 plus m1 v4. This is by the law of conservation of momentum. Now what we don't know is that in case that this collision, the kinetic energy is not always conserved. By the formula, if we want to write kinetic energy as half mv squared, what we cannot tell over here is that half m1 v1 squared plus half, I'm so sorry, it should be m2 v2, so plus half m2 v2 squared is not always equal to, I'm putting a question mark because I have a doubt, that is half m1 v3 squared plus half m2 v4 squared. This should be m1 and this should be m2. Yeah. So half m1 v1 squared plus half m2 v2 squared is not always equal to half m1 v3 squared plus half m2 v4 squared, because when this particular ball or this object is going to hit this object, a part is going to be lost. That means the kinetic energy will be lost in terms of noise, in terms of heat. It can be light, it can be anything. So in case that the energy is conserved, that means we are going to get equal to the kinetic energy is conserved, it is called an elastic collision. It is called an elastic collision. And in case that the kinetic energy is lost, that means it is dissipated in terms of noise or light or in terms of heat, it is going to be called inelastic collision. So I would just like to repeat that this is the general law of the law of conservation of momentum. It would always be equal to this collision before and after. But in case that we are getting a kinetic energy, we cannot call this kinetic energy as always conserved, because in case it is conserved, you will be told, and it is called elastic collision, or otherwise it will be called inelastic collision. And we are going to look more on elastic and inelastic collision in my next videos. Thank you for watching.